This is Physics Chapter 8, Problem 22. A 20-kilogram floodlight in a park is supported at the end of a horizontal beam of mass that is hinged to a pole, as shown in figure P8.22. A cable at an angle of 30 degrees with the beam helps to support the light. Find A, the tension in the cable, and B, the horizontal and vertical forces exerted on the beam by the pole. So you copy this diagram down. So you know that this is 20 kilograms, and so you have your x and your y, and I'm making this distance d, and then you know that this angle is 30 degrees, so you know that when you go up you have to do the sine of 30, when you go across you have to do the cosine of 30. And so for part A, you're trying to find the tension in the cable. So that is T sine of 30 minus the weight of your cable, the weight of the light bulb at the end of it. And so both of these should have the distance, but that ends up canceling out since that's equal to 0. So then and that gives you the tension of 392 newtons. And then part B, you're trying to find the forces, the horizontal and vertical forces. So in your x direction, you have that force minus cosine of 30, minus the tension times the cosine of 30, sorry. And that is and your tension you got from part A, and so the force in your x is 339 newtons to the right. And then in your y direction, you have the mass of the weight of the light bulb times sine of 30. So then you get 196 newtons minus 392 newtons times sine 30, and so the final answer is 0 in your y direction.